Hi guys, this is the last topic within Simplex algorithm, and then we've only got one final chapter to go, and the last chapter is absolutely lovely. I think you'll really enjoy it. This chapter is definitely the hardest one in the whole book. So Simplex method, the Big M method is very similar to the two-stage method of the Simplex algorithm, and you'll notice we achieve the same thing. We just have to manipulate with some algebra, which makes it a little bit, just not as nice as maybe the two-stage one was. The numbers were a bit easier. You'll see what I mean. So the idea here, it's mainly this bit we're looking at. This bit here. So in the two-stage, we introduced artificial variables because we had surplus variables. We still have the same thing here, surplus and artificial. And we used the first stage to make these artificial variables go to 0. Then we began the second stage. Well, what we do here is we subtract m lots of the artificial variables, and by doing so, this ensures that the artificial variables end up being pushed to 0. So m, we don't actually know what the number is, but we just assume that it's a really big number. And that way, these end up getting pushed to 0. So it's the same principle with what we're doing, just in a different technique to the two-stage. This is question 4, and I thought we'd go through it together. And then you can have a go at these, some other questions from the exercise. So you'll see here we've got a objective function, we've got a constraint here which will need a slack variable, and we've got here one that's going to need a surplus and an artificial variable. So the first thing we're going to do is to rewrite these. Okay, so if you were to look at the question, they've split this up into sections. So in total, it's a 15-mark question, which is fairly standard, but it's quite unusual to get you to carry out the entire iterative process. They often only get you to do one tableau in the exam. So we've got P is going to be equal to 3x plus 5y take z, and I'll have to do something with that in a second. My first constraint, x plus y plus z, but remember I'm going to need a slack variable in here. I'm going to use r. In the book they're very keen on using S1 and S2. Next constraint, 3x plus y plus 2z. Now here we need an artificial variable and a surplus. So remember, because the inequality is greater than or equal to, I need to take away an amount. That can't be negative. Okay, this variable here can't be negative. And if we started off with x, y, z were 0, then this would end up being negative, which we can't have. So in order to account for that, we add in an artificial variable. Okay? Now, how I have to change the objective function here, back here, we talked about subtracting this from the objective function. I've only got one a here, so I don't have to add a1, a2, etc. But I do need to do this stage where I'm subtracting m lots of a1. Okay, and that a1 will need to be changed because I can't keep the artificial in the objective function, because remember, it doesn't really exist. So I'm going to put m and then brackets, and I wish I had a bit more space here. Let's see if I can move some of this over. That's a little bit better. So I now need to change a1 using this equation here. So you imagine if by any chance we had like A1 plus A2 plus A3, that's really bad, isn't it? What I'd have to do is rearrange A1 here, rearrange A2, rearrange A3, and that would be massive. So fortunately, we've only got A1 here. So I am going to rewrite that second constraint. So 24, and then it's going to be take 3x, take y, take 2z plus s. So I've now got a lovely new constraint here. And what I'm going to do, I'm just going to pause it whilst I move some of this stuff out the way. Okay, I have a bit more space now. Now, let's try and simplify this down. Okay, so, oh my goodness. What I'm going to do is try and collect all the x's together, but what I think I'll do at the same time, because I want it in the form like we have in the other ones, where you have p take away all of this stuff, and then that's equal to naught. Okay? Only this time it's not going to be equal to naught. It's going to be equal to a certain amount of m's, because we're going to have a constant in there. Okay, so it's going to be a constant on the right hand side rather than naught. So let's try and group these together. Okay, so I'm going to do p take away, then I'm going to do my x's. So I'm going to have, I've got 3 lots of x, and then from over here I've also got a positive 3mx. So I've got plus 3m, so that's my amount of x's. Then I'm going to do the same thing with my y's. And I'm doing takes rather than pluses and making these minus in here, because remember, I want to have minuses in the objective function. Okay, and then take, then I'm going to do my z's, 2m plus 1z, plus I've also got m lots of s, and that's all equal to minus 24m. Okay, so really unpleasant to do, but it's algebra, isn't it? So I took everything over to the other side to join p, keeping these minuses in here, but 24m is going to stay on the right hand side because that is a constant. Okay, all the other things aren't. Okay, this is not a constant, that's a variable. So if you're following the question, that's done part B. So far we've got 5 marks for everything we've done. We now need to put this into a simplex tableau. So let's put this into the first tableau. Quite often in the exam, this is all they ask you to do. And then they might give you the last tableau and ask you to analyse it and write down what the solution is. Okay, so I've copied across my equations, my objective function, my constraints. Basic variables, so any slack variables are basic variables. Any artificial variables, remember surplus are not basic variables. So any slack variables and any artificial. So you've probably noticed that I've put S when I should have put R. Okay, so I'm just going to change this. So that should be an R in there, and that should be an R in there. Sorry, I actually do not know my alphabet, that's the problem. Okay, so that should be an R in there. Okay, and the other one was an S. I do apologise. Okay, so R's my slack variable, and S is my surplus. So let's fill in our first tableau. So we've got 1x, 1y, 1z, 1r, no s's, no artificials. That gives us 20. Next one, 3x, 1y, 2z, no r's, minus 1s, 1 artificial, and that gives me 24. And then this weird one at the bottom, this kind of fills me with absolute dread. Just the thought of it. Right. So, negative 3 plus 3m, negative 5 plus m, negative 2m minus 1, naught, m, naught, and that gives you 24m. At the moment, I am absolutely cursing the person who came up with this big M method. Okay, now we're going to do the iterations, and I warn you, there are 4 tables to get through. Well, maybe 3 or 4 tables to get through until we get to the correct solution. Okay, so the question in the book asks us to do this for 2 marks. So all of this work here, 2 marks. Now we need to carry out iterations to solve the problem, and it's 8 marks. Again, remember, if this was the exam, you would not do that much work. You would do 1 more table maximum. Okay, they're not idiots. They don't want you just doing this again and again. If they can see you understand it once, that is absolutely fine. Okay, so let's have a look. Now remember, M is a big number. Okay, so if M's a really big number, then your most negative number here is going to be that minus bracket 3 plus 3m. I know it's a little bit tricky when you haven't got an exact value of m, but just remember it's really big. You know, treat it as 1,000 if you like. So if we work out our thetas, we've got 20 over 1 and 24 over 3. So this is going to be our pivot row. That is going to be our pivot column. So the first thing I'm going to do on the next table is to divide all of this by 3. What I will then do for this row, it's got a 1 there, that's lovely. And remember, that's going to turn into a 1. So all I need to do is row 1, take away row 2. But this one, oh my goodness, okay, well, to try and get that to 1, I'm going to have to add on, to get it to 0, I'm going to have to add on 3 plus 3m lots of row 2. Okay, so let's do that together. Sorry, I can't get the tables on the same page. They're a bit too big. So that's still R. This is swapped for X now. So this one is row 2 divided by 3. So this is okay. I can do this. 0 minus 1/3. Just keep telling yourself you can do this. And then back here, I need to do row 1 minus row 2. Okay, that's okay too. And when you do the big M, it kind of makes you think, oh, actually, the original Simplex isn't too bad. Give me the original Simplex any day. So that's row 1 minus row 2. Okay, now what is lovely and what always seems to happen is when we do these row operations, we get rid of a lot of these M's, so it's not as painful as you think. So I need to add on 3 plus 3m lots of row 2. And you'll see what I mean. It simplifies down a lot quicker than you realise. I'm just going to fill these in. And you get negative 4, 3, 0, minus 1. You still get an m in there. But that goes to 24. Oh, thank goodness. You'll probably find when you do these for the first time, or even for the whole time you do this kind of technique, you might want to write down the equations you're doing underneath just to help you out a little bit. Because these ones do end up as equations rather than just a simple calculation. Okay, so like here, you're doing minus bracket 2m minus 1 plus 3 plus 3m lots of 1. So you've got, there's a bit of algebraic manipulation there to do. It's quite challenging. Okay, let's look at where to go from here. Well, Again, the most negative here, oh well, it's really lovely, isn't it? Okay, it's this one. So let's work out my theta. So I've got 12 divided by 2/3, so 12 times 3 over 2. And I've got 8 divided by 1/3, so 8 times 3. So the smallest one here is this one. Okay, that gives you 18. So that gives you 18, that gives you 24. So I am going to have this one as my pivot element. So in the next tableau, I'm going to times all of that row by 3 over 2. I will then, to make that go to 0, I will take away 1/3 lots of the first row. And to make that go to 0, I will add on 4 lots of the first row. So already it's so much nicer. And what we need to do here, if you notice here, my Y is interchanging with my R. It's really nice when this happens and you actually get the X and Y in there. It kind of seems like it's normal. So I'm going to do 3 over 2 lots of R1. 0, 1, 1/2, 3 over 2, 1/2, minus 1/2, and 18. This one I had to do R2 take away 1/3 of R1, and I get 1, 0, 1/2, minus 1/2. I suggest you kind of go through this yourself and just check with me. I have checked it all with the mark scheme, but you can never be completely certain. I'm very prone to making mistakes, especially when I'm recording. I find this all very, very nerve-wracking. I'm really not enjoying all of this use of technology. Very nerve-wracking. Okay, so unlike with the two-stage method, that always stays here. The artificial variable stays there, but we'll never actually use it as part of our solution because it won't ever become a basic variable. So you don't need to worry about that. Okay, but it lives in there, doesn't it? It doesn't disappear. So what we can do now, this is not negative because m's really big. It looks like we've got our solution. So it wasn't as bad as we thought, was it? When we started off with that, with all those m's in, it looked horrendous. And actually a couple of tableaus later, we've got the answer. And I've only taught you the shortcut method for the tableaus. Generally, you do the row operations on separate tables, and I never showed you that way because it's pointless. You would never do it that way. You just do the shortcut method. But if you can imagine doing a separate row operation, we'd be here all day. So we have now got P equals 96, X equals 2, Y equals 18, and all the other variables that do not have pride of place in that basic variable column do not have a value. So we need to make 2 of these X's, 18 of the Y's to maximise our profit or whatever this is, and R, S and A1 are all 0. This is like a perfect solution. All of your slack variables, your surplus variables, your artificial variables, they're 0. This is just like perfect. And let's write our objective row out as well. Let me just get rid of this. Maybe I'll write it a bit smaller over here actually. So X equals 2, Y equals 18, R equals 0, S equals 0, A1 equals 0, and P equals 96. So P plus 5Z, I had that covered then, I couldn't see it, plus 6R plus S plus M minus 1 lots of A1 equals 96. And if you wanted to have this sort of rearranged, you could write it as 96 minus your 5Z minus your 6R minus your S. And remember, if the question is something like, right, how do you know that it is the final tableau, you've got an optimal solution, you can say, well, none of these are negative, so I can't perform an iteration. but you can write it like this and explain that by increasing any of these, what will happen, because they're all negative here, this will decrease the profit, which is obviously not what you want. So if you are asked a question about how you know it's the optimal solution, you talk about these not being negative, but also rewrite it like this, so you can say any increase in these would cause a decrease in profit. Okay. I have some questions for you to try. They might take a little while. I would suggest, if you haven't done already, use that code at the front of your book and get the solution bank for this, because then you can see the answers step by step, tableau by tableau. I'm just looking at the questions I've asked you to do. Question 1, I think they only ask you to do, yeah, not a lot. There's not a lot of work involved in question 1. Well, I tell a lie. There's a lot of work, but not a lot of tableaus. So you've just got to answer the questions on that and do one iteration. So that's not horrendous. Question 2, again, you're just doing the initial tableau and doing a few explanations as to what everything means. And then question 3, you're doing a minimise one, so be careful with the minimising, okay? So please be really careful with the minimising, but actually you've only got one tableau with that as well, okay? So you haven't got a huge amount of tableaus to draw out. Best of luck. Please let me know if there's any kind of support you need on this chapter, because once we do the next chapter, we'll have finished all of the further. We've nearly finished the A level. We have got plenty of time to revise, but I'd rather you understand as we do it, rather than try and plug the gaps later. Okay, take care, best of luck, keep safe. Bye.